I'm really happy that you brought up this subject in the energy conference. And it has also been signalized earlier by some presenters and panelists. Yeah, the world's domestic materials consumption, which is equal to materials extraction, has been increasing in the last 2-3 decades steadily. And in 2024, which are the latest data available in Eurostat, this has reached a peak value. 13.2 tons per capita world basis, which is just slightly lower than the average in Europe, which is 13.4 tons per capita. So population growth and industrialization, there are the two main factors that are leading to an increase of global materials demand, which is projected to increase by 30% in 2030. It's a huge increase, right? We use more and more materials as the centuries goes. We use more and more elements from the periodic system with the years. And those materials, in many cases, are considered as critical or strategic, and strategic because of their supply risk implies important economic and strategic consequences. And remember, consumption is what makes us the need to extract and process natural resources into products. I like to highlight in all my speeches that everything comes from somewhere. If it didn't grow, it was mined. Remember that. In the case of technologies behind the energy transition, renewable power, electric mobility, energy storage, critical raw materials are needed in quite large amounts. We are talking about lithium, nickel, copper, graphite, rare earth elements. All of them have experienced extremely large demand in the last years, and there is more to come in the next ones. And per today, as some of you have noticed already, and it has been signalized earlier today, those critical minerals are provided by specific single countries or regions. So the demanding decarbonization goals and the energy transition, and also our industrial development, are dependent on materials that are exported by geopolitical unstable countries and regions. This is a fact. And this dependency, as it is shown in this graph, is much stronger than the dependency on fossil fuels. So on this, I also want to signalize that this is not only the dependency on primary raw materials, it's also a large dependency on processing those materials to obtain the end products that we need for the applications. And in many cases, like it has been also said before, batteries value chains, solar power value chains are controlled as well by single countries or regions. So on this given scenario, there are several strategies that has been proposed to secure critical raw materials availability, as those signalized by the Critical Raw Materials Act by the EU Commission, that Norway seems to implement also. Boost domestic production and further processing, diversifying value chains also here, not only in the energy sector, enhancing material efficiency and substitution, and connected directly with that, increasing recycling and circularity, with the highly demand targets by the Critical Raw Materials Act of 25% of materials should come from recycling by 2030. Recycling, we can say that I could talk about mining, primary production, what are the opportunities, what are the challenges, but today I will talk from the circularity perspective and just signalize that secondary raw materials, end-of-life products, may constitute a large resource of critical raw materials. especially waste from electric and electronic equipment. What is called e-waste is the largest increase in waste streams, is increasing 2% annually, and it composes a large majority of metals. So, of course, I can say the big energy and environmental savings that is related with recycling. Here is some data about aluminum and steel, which are two of the most recycled materials per today. Environmental impacts are saved, natural resources are saved if we are using recycling materials. Steel from automobile is per today 90% recycled. It's also a new metallurgical industry. There are large amounts of critical raw materials also in this electronic waste, estimated around 1 million tons of critical raw materials. There is rare earth permanent magnets in end-of-life products containing neodymium, dysprosium, terbium. There is gold and platinum group metals, PGMs, in printed circuit boards, also tantalum, copper, and in many cases in larger amounts than there is in the ores. So it's definitely a very nice resource potential there, and the availability of recycling feedstock from energy sector is predicted to be very, very large in 2050. I also want to signalize that recycling doesn't avoid the need of primary supply requirements. It is estimated that around 25 to 40% will still be needed. So recycling is not only the solution to have availability of critical raw materials, because there are many, many challenges. There are not so many critical raw materials that are recovered per today from end-of-life products. There is still a lot of challenges. I signalize here 4 of them. There is still insufficient collection of end-of-life products, e-waste. The targets in the EU is 65%. We are lying around 50%, despite the infrastructure is getting better and better. And also in energy technologies, there is a long lifespan of solar panels, electric vehicle batteries, and wind turbine generators, of course. In addition, is a large complexity of end-of-life products. Unfortunately, they are not designed for recycling. Eco-design is more like a utopia per today. So it's very complex end-of-life products. Recyclers, they are relying on shredding operations, and then critical raw materials are usually diluted and lost in the ferrous fraction streams. And this also gives to very complex recycling chemistries as well. So this is one of the factors why many technologies are not deployed on industrial scale per today for recycling. And in the end, it's economical viability as well. Is it cheaper to buy a primary critical raw material from the market, where single countries are establishing the prices? Yes, so recycling materials and recycling opportunities are not economically feasible. Well, here is just the points that I want to summarize from my presentation, but I leave it just here. Thank you so much for your attention.